Hello everyone, welcome to this tutorial. In this tutorial I would like to discuss about stepper motor interfacing. It's part of the one of the experiment that we did it in the lab. So this experiment we would like to do it today. We are using 89C51, though we are having 89C51 RD2 ET2 in the lab, because in the simulation software we have only 89C51. We are going for 89C51. This is the code and you did everything in the past. So what I do, I'll just copy down this code. Before doing that, you just have to select Keel Microvision to build the project. Go to project, new project. I'm going to save this project in one of my folder. So select the location. So what I do, I'll create a new folder for this. I'm giving a name as stepper motor interfacing with 89C51. So I give stepper, give project name. This is the project name. Can be anything like interfacing. Give meaningful name. Okay. Save. This is the project name. So in Atmel we have 89C51. 89C51. So this we have to select for this. Say OK. Since we are writing C program, you say yes, so that startup file will be getting added. Just now I said this is the startup file. So what I do, I'll take this control N or new. Here I have to type the code. So what I do, I have a manual and I have given the code for you. So what I do, I'll just take this code and paste it here, and then so instead of this, I think I have recently typed a code. I'll just open that. Okay, this one, I'll select everything and I will add it. So you are supposed to type this if you don't have code. However, we have given it in the manual, so you just copy and paste that code. Since intention of the tutorial is to get the simulation of the stepper motor interfacing, not about typing or coding or anything. Okay, so you thinking that you know everything, so we are going ahead. Stepper motor, save this file with the dot extension C. .c. Now you should add it to project. Add stepper motor, and then you are supposed to build it. If you have any errors, you will get those errors here, and you are supposed to build the hex file. For that, you go for options, go to project options for target one, or there is a shortcut here, output, create hex file, and then you have some other these things, but not necessary in this. So just do this, say OK, build, so that hex file will be created. Okay, so once you created that hex file, you are done with the coding and you got hex file. You are supposed to do it, but you can check it also in the debugging mode, whether in the port 2 you are getting the output or not, expected output. If you run it, you could able to see those codes what we are intended to get at the stepper motor. Okay, so now I am getting it from the point of keel. Now I am supposed to do it in the simulation. So what I do, I'll open a software called as Proteus. Okay, I have two versions, 8 and 7, so I'm simply opening the primitive version of this Proteus 7.7. So here I have to select part name. Here you just simply select part P, there's a P. Okay, here you can to get the part name. Okay, if you are in the some other thing, you may not get. Okay, so for example, if you click here, you may not get part name, so you should click on this component mode, then only you get part name. So here you type 89C51. Okay, so there are varieties. What we used in the lab is 89C51 ED2, so which is not there. Nearest one is RD2. That's also okay, but this is sufficient for you at this moment. Say okay, click on this. So you got the part. This is microcontroller. Next part what we needed is motor. Click one more time, click on type motor. Kind of motor that we are required is stepper. Okay, motor. Okay, are there any motors? You just check. Okay, stepper motor. This is a driver, I think. Here, animated. This one you are supposed to take, not this one. Okay, this is what we needed. That may also work. This by stepper. Take this part and keep it here. So what we need in between, because microcontroller cannot itself drive this 12 volt stepper motor with a huge current, so we need a driver similar to that of an EVLN driver. EVLN 2003 is okay for us. All the things are okay. You just check TTL to this. Okay, this is sufficient for us, this lab. Okay, EVLN 2003. I think this is sufficient, EVLN 2003. What we have in the lab. So I am taking the same thing what we have in the lab. Okay, then you can zoom it. I can zoom a bit so that you can do interfacing. So we have connected the motor thinking that it is interface to port 2, P2. So we are supposed to connect port 2 to 4 of these. One click here, one click there. So what you can do is initially itself you can plan. You can do undo. So what can be done is you take it up a bit. Okay, you go in select mode. What can be done? You push it up or you pull it down. Okay, then you can take up. You can place them very closely, nothing wrong in it. So I have 4 lines connected to it. The outputs are connected to, okay, 1C, you can connect it to the first one. Then 2C is connected to second one. Then the third one, you are supposed to connect it to third, which is somewhere here. This is third. Fourth one, you are supposed to connect it to the fourth one. Okay, so this is fourth. This is the connection, but we are supposed to give supply something like this. Okay, and give it to 12 volt. Go here. So this connection is over. Now I am supposed to give 12 supply. Can give power. Then give it to select, click here. You can also give DC supply, nothing wrong in it. You can go to where is it? Here you can take a DC and you can connect a DC supply, nothing wrong in it, and you can give 12 volt, or you can rename it and you can give 12 plus 12 here. Say okay. So this is about the connection, but you are supposed to give common as well. This must be connected to ground and all those things. But that is also okay. Even if you don't connect by default all the connections, it will take to ground. So you can take that. Okay, I think I missed it. View all. Take ground and connect, and you can rotate and connect. Okay, there is rotate part, that also can be done. And the shortcut is okay, I don't need shortcut because only one connection is there. I'll zoom it. So if you even if you don't connect, you may get the output, but okay, no problem. So what I do now, I'll try to dump the code in this. The next step, you just save it wherever you just selected. Carefully you save it, so don't save somewhere here and there. What I do, I'll save it in the same directory where I saved this stepper motor microvision file. Okay, so just saved it. It's good to save. Even without saving, this can simulate. Then right click on microcontroller, edit properties. I am showing again, right click, edit properties. Here you select 11.0592. instead of that 12 mega is there. It's okay, nothing wrong. Then I'm just ensuring that I'm taking the same hex file. Okay, say okay, and you are ready now. And if you run, you should be able to see the motor rotation. There's something wrong with it. I'll just check what is wrong in it. Yeah, I think something wrong with the connection. You have to just check what mistake I did. Okay, 1 is given to 1, 2 is given to 2, 3 is given to, here I made a mistake. What I am supposed to do is, these two connections are interchanged. This is third one and this is fourth one. Yeah, fine, I think this should be working now. I'll zoom a bit so that you can see the working of it. If I run, I should be able to see now the working of it. This is anti-clockwise. Okay, now if I want to change it to clockwise, I have to go back and check and make this as 1. Okay, I think earlier 1 for clockwise, 1 for clockwise and 0 for anti-clockwise. Okay, just save and build. Once you build, come back and just save here and run it. Now it should go clockwise. Can you see now it's running in clockwise mode? Yeah, this is all about stepper motor, and see you in the next tutorial. We can change some additional features here. Instead of giving our data in the program, you interface a key to it. Okay, interface push button. If push button is our switch button. If it is 1, you can make it clockwise. If it is 0, you can make it anti-clockwise. Something like that you can make. Okay, so do that as an exercise, and and see you in the next tutorial.